Hello, and thank you for joining us for our webinar with Hive MQ. I'm Nick Holt, editor at AMS. For this presentation, I'm joined by Ian Skerritt, Vice President of Marketing at Hive MQ. Ian has over 25 years of experience in the software industry and is one of the top experts for creating open source strategies for enterprise software products. Today, Ian's going to be focusing on how MQTT can be implemented into factory software infrastructure to drive efficiency in production processes. But before we begin, I'd just like to invite all of you to send some questions for Ian to pick up in the Q&A session that will follow the presentation. Just type the questions into the lower right-hand side of your screen, the small box down there. And also, if you experience any technical issues during the session, please let us know using the same box and we'll try and fix it. Just before we hand over to Ian, we have a poll question for you. So that should be coming up onto your screens. So basically multiple choice. If you can just answer the question. So here, what statement best describes your current IoT strategy? 4 possible answers there. Thank you for that. So now we can join Ian. If you want to come on screen, Ian. Thank you.
Sure.
And I'll hand over to you for your presentation. Thanks very much.
Great, thanks, Nick. So if I can kind of share my screen, please. Right, so hopefully you can see my, can you confirm you can see my screen?
Yes, on screen, that's fine. Thanks, Ian.
Perfect, all right. All right, well, welcome everyone, and thank you for joining us today. I'm very looking forward to having this conversation with you. And certainly, as Nick said, please, there'll be lots of time for questions at the end. So please leave your questions in the question Q&A area, and we'll be happy to start to address them. So what we're going to talk about today is kind of modernizing your software infrastructure, the manufacturing software infrastructure. And we're going to be talking about how we believe MQTT is a really good solution for a lot of the challenges existing infrastructures have today. So Nick already talked about myself, so I'll kind of skip over the introduction. But I am the head of marketing at Hive MQ. Just a quick update, kind of introduction to Hive MQ, where it's a German-based startup. We're based outside of Munich in a beautiful Bavarian town called Landshut. What Hive MQ does is we help people, we help companies move data to and from connected devices. And we do this in a very reliable and fast manner. And the device could be a piece of factory equipment, it could be a robot, it could be a connected car, it could be a connected dishwasher. So it's very broad, kind of the use cases that we can address here. We're going to be focusing in on the manufacturing use case, but we have a large number of customers in production today with IoT applications. Just to give you a sense of kind of where the different types of use cases we do address. So today, if you buy a BMW or an Audi car today, all the connectivity between the car and the cloud is done through HiveMQ. So connected car mobility use cases is a big use case for us. Manufacturing and industrial automation is kind of what we're going to be talking about. We'll go into specifically around automotive manufacturing. Transportation and logistics, so kind of trucks, fleet management trucks, public transit with buses moving around a city is an important use case for us. And the final area is things like connected products to connected assets. So solar farms, wind farms, oil and gas, etc. So there's a wide variety of use cases that we do. We're going to talk about automotive manufacturing, so I thought I would kind of lead off with an example use case. So Daimler uses us in the plant floor. They have a system, a vehicle diagnostic system. So this is the system at the kind of the end of the manufacturing process where you kind of do the final test of the car. You kind of program the key fob, kind of do the kind of the final provisioning of it. So there's a piece of equipment that does this, that's connected to various back-end systems to get all the information that they need to do to kind of get the VIN numbers, etc. put in. And all the communication is done with HiveMQ to the backend systems with the equipment on the plant floor. As you can imagine, this is a very critical part of the process, so this system can't go down. And that's kind of going to be a consistent theme here. It's kind of reliability of the system is where we come in. We kind of, it's really important that the systems that you put in place have the scalability and reliability that is expected, because you don't want your plants to stop working. So let's kind of step back and say, kind of just look at the future of manufacturing. And I think we can all agree that there's tremendous amount of investment going into the manufacturing area. Some people call it smart manufacturing, some people call it Industry 4.0. There's a variety of names, but really what it is about kind of taking a lot of the modern technologies that's out there in terms of things like cloud computing, AI, machine learning for doing things like predictive maintenance, advanced analytics, but also combining that with the improvements in the sensor technology, the hardware technology around automation that's coming down. And this is really where we think the manufacturing industry is going, right? Is combining kind of what I would traditionally call kind of the IT type services with more modern OT type services. And we're seeing a lot of our customers embracing these type of technologies to move forward. And really what they're looking for is some key business drivers. So how do you improve the overall factory efficiency? Kind of the competitiveness of the manufacturing industry is, as I'm sure people on the call can appreciate, very, very extreme, right? And so if you can be more efficient, you can be more competitive. For our large customers, in-plant logistics is a key issue. So how can you kind of better optimize for that? More flexible manufacturing, kind of the lot size one, is always an area that people are looking for. So you can kind of change your manufacturing line based on customer requirements and market demands is a key driver. And then finally, just the overall equipment efficiency, right? So things like predictive maintenance, if you can kind of do maintenance before something breaks, is basically you're kind of improving the efficiency of your overall process. So these are some of the key drivers that we see companies kind of looking for when they kind of start to think about doing these type of projects. But if kind of when you kind of look at these new projects, it's also important to understand kind of the current situation where people are. And I think kind of there's very few new factories being built, right? So most of the projects that we see are existing factories that you're trying to modernize, right? So there's very few rip and replace projects. We're really talking about kind of going into an existing factory and understanding the current infrastructure, and then how can you kind of break down the silos and kind of start to bring the data together. And I think this is probably one of the key challenges with any modernization project is a lot of the data in these factories is very much in silos. And this often is because there's many different vendors on the factory floor with different hardware, different protocols for these hardwares, and often proprietary protocols. So kind of a piece of hardware can only talk to kind of the proprietary software from the hardware vendor, or even there's many kind of hardware platforms that can't talk to anything. Like it's very difficult to get data. Very difficult to get the piece of hardware connected to the internet or to the network. So there's a lot of challenges where kind of if you've got the data in silos, how do you start to do kind of a holistic approach of an analysis? How do you do things like machine learning for doing predictive maintenance? So breaking down these data silos is a key aspect of many of these projects that needs to be taken on. There's also kind of the traditional kind of IT/OT clash. And really kind of smart manufacturing industry 4.0, the success of these projects is really kind of one we find when we work with customers that have very good coordination between IT and OT, then the success goes up. If there's not good coordination between these two groups, then it goes down. And I think kind of this is kind of typical in many organizations where the IT department has different kind of drivers, different goals, different cultures than the OT people. So the OT people are very conscious about factory downtime, kind of security, privacy of data. IT people are often more focused on kind of what's going on in the data center, agility, kind of responsiveness to getting new features implemented. So kind of addressing this is important because really to have a successful smart manufacturing solution, right? It's all about getting data from the factory floor into the IT systems, but equally important, getting IT information back into the factory floor. So it kind of take that on is important. We talked a bit about kind of the connectivity of some of the hardware. But today, there's lots of manual interactions with OT software. And this, kind of, for obvious reasons, will slow down any downtime, any kind of upgrades of software. Kind of, so this can become a big issue. And really, kind of summation of a lot of these problems is it's very difficult to scale. It's very difficult to kind of bring up a new line, bring up a new factory. If something goes down, the downtime can be quite significant because kind of the software is not well thought out and not well connected. So kind of if you step back and say kind of what are the goals that we can achieve from modernization, and I think kind of when we talk to our customers, it really comes down to these 4 goals that they're trying to achieve. They're really looking to kind of have more agile software delivery. So in this back from the IT side, where kind of agile software development is a common practice in most IT organizations today. And they're really looking to try and bring some of those best practices into the factory environment. Faster mean time to recovery. So kind of really, if there is a problem, and there always will be problems, right? How do you kind of recover from those problems in a quicker manner? And gains back to kind of lessening the downtime of a factory, which is kind of core to the success of a factory. Kind of kind of more central command and control. So you don't have to be going out and manually interacting with your equipment. Can you kind of control the equipment, maintain the equipment from a central location? Can you start to visualize the overall process from a central location? Is the third goal. And then finally is this can you bring kind of more consistent, flexible architecture to your factory floors? And the flexibility comes from make it easier to introduce a new line, new piece of equipment, new piece of software, that you're not getting stuck with kind of the current environment that you're in. Right, because that's how you start to future-proof your architecture. If you have flexibility, you kind of in the future you're not sure what other software you're going to want to use, right? So if you have an architecture that allows to introduce new software in the future, it's going to be much more beneficial in the long term. So let me just get a quick drink of water here. So the levels of factory automation are certainly well known, and I think the key challenge here, right, is how do you get consistent, reliable movement of data through these levels, right? How do you pass information from the production, the field level to the control, the process management, operation, and to the corporate level, right? And then how do you pass information within each level too? And I would submit that if you use the way you do that needs to be consistent, kind of both within the levels and going kind of between the levels. And I think this is kind of from a kind of an architecture point of view, kind of where people are thinking of kind of how do we start to think about what technology to put in place to be able to do this. There's also kind of in terms of kind of common architectural patterns that we see where within a factory you're connecting the automation manufacturing factory to the cloud, but you're also thinking about how do you connect between factories. Many of our customers will have factories around the world, and each factory needs to be autonomous, right? But you also want to be able to share information from each factory with a corporate data center. So you can start to look at trending information between factories. You can have kind of a central view of your overall manufacturing environment, but each factory is also relatively autonomous too in their operation. So those are the kind of two patterns that we see within our customer set. So to kind of to look at kind of what needs to be done to take this on, right, is kind of back to this kind of the connectivity across all the levels of automation. You need to have a consistent data messaging across these areas, and security is also very important, right? Kind of the security of the factory, the security of the information being passed kind of certainly outside of the factory or within the factory. And the final thing is that kind of there's still a lot of different hardware suppliers. There's still a lot of different non-standard protocols and platforms in each of these factories. So how do you kind of work within that environment? So this is where I'd like to kind of step back and kind of start talking about MQTT. And MQTT is probably kind of the most popular IoT protocol out there. It was developed in the late 90s in the oil and gas world to instrument pipelines, oil and gas pipelines. But it's since then, since kind of about 2014, it's really taken off in terms of for IoT use cases of how you kind of connect devices, how you move data from devices and move data back to the devices. It's based on a publish subscribe metaphor that we'll go into a bit later. One of the keys of MQTT is the client is very, very lightweight, so it's very small. So it can fit on very small devices, but also from a bandwidth perspective, it's very, very small too. So it doesn't take, an MQTT message is just very small and it doesn't require much bandwidth to transmit. It's been designed very for remote areas, right? So things like oil and gas, and this is really important for doing reliability over unreliable channels. Not as relevant typically in manufacturing, but some of our customers, even on factory floor, can't rely upon constant internet connectivity due to Wi-Fi configurations, etc. So being able to have a messaging infrastructure that supports network drops is very important. Quality of service is key for many IoT use cases, and MQTT 5 is the most recent one that we think is really the best option for IoT situations. So in summary, MQTT offers this decoupled architecture where your clients don't need to know about each other. The clients connect to a broker. They use a publish-subscribed protocol. It's really easy to add new clients into an MQTT scenario. And as we talked about, it can be highly reliable. So just to go into an example of the pub/sub pattern. So if you have some type of sensor let's call it a temperature sensor that would be publishing some type of temperature on a intermittent basis or whenever the temperature changes, that the client would publish to the broker. There's also a number of different clients that say they want to get access to that information. So they would subscribe to all messages of temperature. And so when a temperature message is published, the subscribing clients would receive that message and from the broker, right? So the machines, the backend systems don't need to know anything about this sensor, and this is where it becomes decoupled. And this is really important when we get into the architecture within a factory, where you can start to introduce new subscribing clients, right, to information that's already being published, right? So back to being able to future-proof your architecture. So on top of MQTT, there's another specification that I'd like to introduce called SparkPlug. And so SparkPlug basically is being defined as in the open source community to really enable this plug and play interoperability with IoT devices and applications. So SparkPlug defines on top of MQTT things like topic namespaces, a consistent data model, basically allows you to define process variable payloads, and also does the MQTT state management for you. So if you can think about SparkPlug as MQTT is basically very much payload agnostic, SparkPlug starts to define a consistent payload of how devices need to publish information and applications need to consume information, subscribe to that information. So from there, then we can start to say, okay, how does this fit into our architecture? So if you think about today's architecture, where we talked about the data silos, you really get this spaghetti type of environment where a gateway would be hardwired to a SCADA system, a PLC would be hardwired to an MES or a historian, and these would be potentially different vendors, different hardware providers that basically when you add in new hardware or add in new applications, you need to do these pairwise integrations to get the data to these different systems, right? And this obviously can't really scale very well, and it makes it very difficult to diagnose problems, but also to add new applications or to add new lines, to add new equipment, right? So this is where we are today. Where MQTT and SparkPlug allows you to get to is this really very much a decoupled architecture. And let's go through this, right? So the devices and sensors today, right, would be very much often what you have today on your factory floor, right? So we're not talking about a rip and replace here, but we kind of have the different protocols. So OPC UA, Modbus supported, different devices, sensors, there could be digital or analog inputs. And then what MQTT and SparkPlug define, right, is what we call edge of network nodes, right? So these would be either software or hardware or new PLCs that sit in front of the devices and sensors, gather the input, ingest the data from the existing equipment, and convert that data into MQTT SparkPlug messages, right? Those messages would be published and subscribed to from a broker. There's a SCADA host that coordinates everything, all the actors in the system. And on the application side, the different types of applications, so it'd be an MES system, historian, analytics, different kind of applications that we haven't even defined yet, right? We'll be able to understand how to subscribe to SparkPlug messages and process those messages. So what this allows you to do, right, is that if you need to introduce a new piece of hardware into your system, right, you just introduce a new edge of network node that only needs to know about the broker and only needs to publish to the broker. The MES system historians, right, don't need to change, right? So they will automatically recognize that a new gateway is available and will be able to start processing the data without any changes here. Similarly, if you want to add kind of a time series database, maybe a Grafana dashboard, you can add this in without the hardware being to make any changes. So it's very powerful in terms of the flexibility it provides, and certainly reduces the time of the maintenance and time of kind of creating new environments. So the key concepts that we find with SparkPlug is this continuous session awareness. You always know the sessions that are available from the hardware through the SCADA system. The report by exception is that it's not a poll response. I think this is an important differentiation between things like Modbus, where you always need to poll. With SparkPlug and MQTT, the client only needs to publish information when it thinks it's important that information needs to be available to the system, right? So there's nothing that's polling the hardware. The hardware and the PLCs know when to publish. Kind of consistent data format. And then the auto discovery comes in with the state management. So this is basically when you introduce a new piece of hardware, the historian, the MES systems can auto discover that because of the system is decoupled for that, right? So it's very powerful systems for doing that. So that was within a factory. When we start talking about interfactory, it's very similar, right? And I think so for interfactory communication, you can think of each factory having a broker working either within SparkPlug architecture or not. And then MQTT has the capability what's called bridging, right? So you can actually bridge brokers, between multiple brokers. And the idea of the bridging is that you define what information you want to send from a factory to a data center broker. So between the two brokers, you define the topics that you want to move between the two. And so you can set up an environment where multiple factories. We have some automotive, some of our automotive clients have upwards to 100 different factories, all brokering into a common data center broker. And from there, you're able to do a lot of the IT services. I think the important thing is that kind of from a security perspective, these are all using TLS. So kind of very common, very kind of tried and tested kind of internet security protocols. to make sure the information is private and secure. Things like client authentication, authorization is also enabled with MQTT. So from a security perspective, we feel this is probably kind of the most secure environment that you can kind of set up, where you want to be able to kind of do this inter-factory connectivity. From an availability and scalability perspective, we can talk a bit about that when we get into kind of specifically about HiveMQ, but kind of from a throughput and number of connections point of view, MQTT is very well suited to handle high amounts of data. So within the data center, HiveMQ works in a clustered environment. So you have multiple instances of a broker running on, you could just do it on bare metal. You could use things like Kubernetes or OpenShift to be able to do that. And the key is that your other enterprise services can subscribe to the information that they want to store in a data lake or an analytics service. HiveMQ actually also has a managed service. So if you didn't want to run your own brokers, we can do that for you too, which we'll see a lot more people interested in kind of having kind of outsourced or having kind of the broker managed by people who kind of really know how to run these at a large scale. So quickly going into kind of the implementation. So from a HiveMQ perspective, we are a platform, an MQTT platform. We talked a bit about the clustering technology. The key with the clustering technology is that if one instance of a cluster goes down, the other instances can take care of the clients themselves. So if one of the nodes goes down, all the clients that are connected to that node will get redistributed to the remaining clustering nodes, right? And so this is where the reliability comes in. Because if like an MQTT broker can become a single point of failure in a system, right? So to kind of work around that, we're using clustering technology, which basically kind of what the cloud uses to provide reliability. So very, very common technology. We've done a lot of work in terms of making sure that the data is not lost when a node goes down, right? So the data for a clustered node is always replicated across all the nodes in real time. So it reduces latency and reduces data loss in terms of from a high availability and reliability perspective. We also have what we call the control center that provides kind of a level of traceability and transparency into the system. So one of the things people often forget about is when you deploy out a system like this, it's how do you diagnose, kind of troubleshooting of a client that's not working properly. And so we provide the tools to provide a kind of level of observability in terms of how a message flows through the system and kind of what's the status of the clients that are connecting to the broker. HiveMQ also has what we call an extension SDK to provide the ability to integrate very tightly to enterprise systems. So we actually sell a Kafka extension. A lot of our customers typically use Kafka on their back end as kind of the event streaming system. So MQ message comes into HiveMQ. HiveMQ can transpose that message into a Kafka message and forward on to the Kafka cluster that can then use that to connect to different backend systems. You can also connect, you can write your own extension to kind of connect data into things like an SAP system or an Oracle system or a MongoDB or any type of enterprise systems. And so it's very, very flexible. As I mentioned, we kind of work in a public and private cloud environment. We can also work on premise. So in summary, HiveMQ is all about clustering for high availability. We support kind of very high throughput in terms of manufacturing data. We see a lot of throughput requirements in the manufacturing environment. The number of connections typically is high, but if you think about connected cars, we support kind of systems in the millions of connections through connected car platforms. So we're very confident we can scale up in that area. And security and kind of integration is very important. We provide a security extension so you can actually incorporate into the broker the client authentication authorization into the broker. We talked about the control center, and we support MQTT 5. So, I think we're coming to the end of the session. Just as some backup resources, we've got a white paper that kind of goes through a lot of what we talked about here that I'd point people to. If people are interested in SparkPlug, we published an ebook on SparkPlug that kind of goes through in detail the features and benefits of SparkPlug. So I'd recommend taking a look at that. So I think, Nick, I think that's the end of the presentation. If we want to kind of switch over to Q&A, I'd be happy to take questions.
Thanks, Ian. Just before we do that, and that was a very interesting presentation, thanks for that. And it's a highly relevant topic given the developments in the automotive industry at the moment. So thanks for that. We've just got one more poll question for our audience to do, and then we will jump into the Q&A. There we go. What best reflects your experience with MQTT? Great. Well, thanks for your cooperation with that. We'll just go into some questions. Please continue to send your questions in. Any we don't get a chance to answer will be forwarded on to Ian and the team at HiveMQ, and they can respond probably in a little more detail to you later on. Just starting in, some questions a bit about MQTT. I mean, the question here is there any stream processing capability or possibility within it?
So really good question. So I really think of MQTT, HiveMQ as being kind of data from IoT devices. So what we typically do is connect to stream processing system. Typically, kind of people, when you talk about stream processing, you're talking about Kafka. So we'll kind of, they'll call it stream processing or event processing. The challenge with something like Kafka for IoT systems is that Kafka is really talking about kind of connecting streams within a data center. When you go out of the data center, it becomes a bit more complicated. Right? So, for instance, a Kafka client is very heavyweight. Like you need a big computer to be able to run a Kafka client, and so it's really not conducive often to have kind of Kafka out in a factory. Right, and certainly if you get into many kind of thousands of connections, Kafka really doesn't handle a lot of connections very well. Right, so this is where MQTT comes in, HiveMQ comes in. That it's been designed for connecting devices, and so that's kind of how I would answer that question. It's MQTT HiveMQ is very focused on IoT data. And can convert IoT data into a stream processing system.
Okay, thank you. Question here, really a kind of comparative question. How does it compare against, is it Rabbit MQ?
Yeah. So Rabbit MQ is kind of it's very common, kind of an existing kind of advanced bus or messaging bus in systems. There's a couple of things. RabbitMQ has support for MQTT, but it's not complete support for MQTT. So if kind of conformance to open standards is important to you, then RabbitMQ, you should kind of take a deep look into kind of how RabbitMQs implement MQTT. So they miss out, like they don't do all levels of quality of service. I don't believe that they do retain messages. I'm not certain on that, but so there's just some key features that they drop. And that's important because if kind of talking about kind of future proofing, right? If you want to make sure that you can add kind of another MQTT device enabled device in the future, right? You don't want to have an MQTT device that kind of can't fit into your system because it really doesn't speak the same system, the dialect of MQTT that RabbitMQ can support. Would be kind of consideration there. The other thing is that in terms of scalability, we've got a number of customers that have moved to HiveMQ from RabbitMQ because RabbitMQ really isn't a broker. It's not an MQTT broker, right? It's kind of they've added MQTT support through an adapter to RabbitMQ, but it's not a true broker, right? So it doesn't scale like an MQTT broker like HiveMQ would.
Another one. I know at the beginning of your presentation you were discussing your work with Daimler on their production line, and you touched upon this a little bit, which I think is kind of raised a question. From your perspective, your insights, where do you see the sort of biggest challenges in that kind of IT OT clash? I mean, is that a big challenge as you're working with? You've got clients within the automotive industry.
Yeah, so no, I think it is. So I think in our experience, where the projects that have a good cultural match with the OT and IT people, then the projects tend to be more successful, right? So it's the challenges, the motivations of the two groups are often contradictory sometimes, right? So kind of managing the goals of the project, so everyone's kind of a winner there. I think it is certainly important. Yeah.
I mean, this kind of brings on to this question. What are the main kind of business benefits of using MQTT in smart manufacturing projects?
Sure, and I think this kind of alludes to some of the things that I talked to, right? Is if you want to get things like improved factory efficiency, equipment efficiency, you need to have a holistic view of what's going on in the factory, right? And today that's really hard to do because one, some of the equipment's not connected, and two, if it is connected, it's often with a proprietary protocol, right? So the data gets stuck in silos, right? So I guess one solution is you kind of harmonize on one vendor's solution only, right? And within your factory, but I'm not sure that's really realistic, right? So I think the world will be always kind of multi-vendor. And so you need to get to a system where you're using open standards like MQTT to be able to break down those barriers. So I think kind of at a high level, it's how do you improve the efficiency, the competitiveness of the factory, right? And then from there, it's kind of what are the challenges, what are the barriers to do that, right? And in my mind, it's really about how do you get all the data together in a consistent manner, right? And that's what really I think MQTT and SparkPlug provide.
And this brings us onto another question, and something again you touched upon here, and we know it's a kind of big concern. We've seen incidents across the industry. Cybersecurity, big concern for organisations. How do you suggest that companies implement their cybersecurity in an IoT project?
Yes, so with MQTT, we absolutely kind of recommend you use TLS to secure the data being transmitted. So that's kind of the table stakes, right? So you want to make sure all the connections are TLS enabled. There are some use cases where that's not possible, and typically what happens is people are using private networks to do that. If you can't kind of have TLS for a variety of reasons, so you can actually kind of use HiveMQ and MQTT without TLS, and for use cases like that. But I think the kind of the general recommendation is to always use TLS. And then on top of that, right, is about kind of authentication authorization, right? And so you want to be able to authenticate kind of if a client's connecting to a broker, you want to make sure it's a friendly client, right? So that those kind of your equipment, your application nodes need to have some type of client identification, whether it's a certificate, whether it's a username, password. There's lots of different kind of mechanisms to do that, and HiveMQ supports within the broker through an extension to do the authentication check before a client can connect. The second part on that is not all clients are created equal, right? So sometimes you want to be able to restrict what a client can do, and this is where authorization comes in, right? So you can actually set up rules to say, okay, this type of client can only publish on these topics. So we'll only receive this type of information from this client, or these clients can only subscribe to these topics, right? So you can only you can limit what a client can, the type of information a client can get, which I think is kind of the next layer of security in terms of the privacy of the information.
And that must have, I mean, obviously it's an important factor anyway, but it must be an increasingly important factor now, given the data transfer between the supply chain in automotive, for example, down the supply chain. There's a great deal more data and detailed data being shared across from tier suppliers to OEMs, etc. So that, as you just explained there, must be a very critical point that they have to focus on when they're implementing those kind of data exchanges.
Yeah, no, absolutely, right. And so I think kind of instead of trying to create your own security, let's like use kind of the web security that's out there that like most people are using, right? So TLS, and then have really good authentication and authorization rules layered on top of that, so you can scope kind of the purview of each client to the rules that you want to enforce.
Just circling back to the case study you just offered at the beginning about with Daimler, I'm not quite sure how much you can reveal about that, but just in terms of the setup times for that and the sort of scalability of it, you mentioned scalability when you were discussing the platform during your presentation. Can you offer any insights into that particular project?
So unfortunately, I can't, but I think so. I think the scalability is there's kind of comes in many different ways, right? For a system, certainly in the manufacturing world, it's scalability with throughput, kind of how many messages per second you're putting through, right? And so we can kind of handle thousands of messages per second quite easily with a broker infrastructure. So that's not the case. I would submit though that often we get into situations where people are transmitting tags, right? But this is actually the old architecture of a pull response, where you're always transmitting tags for the polling, right? Often what we find is that you actually don't need to be, with MQTT, if the client's actually smart enough to know when the data is changed, that's really what the information you want, is when the data is changed. So if a temperature gets outside of a range of temperatures, that's when you want to take action, right? If the temperature is always at 70 degrees Fahrenheit or 20 degrees Celsius, right, you don't need to take action, right? So if you can, with MQTT, you can get smart about kind of when you do transmission, right? So we often actually have to kind of have that discussion with clients that are kind of using the old kind of the old mindset of kind of always transmitting data would be one point I make. In terms of number of connections is also scalability. It's less of a concern in the manufacturing world, but as I mentioned, kind of connected cars, it's definitely a. You can then go into kind of how you organize an MQTT system in terms of scalability of kind of number of topics and stuff like that. But I think we have yet to kind of come across a system where kind of we couldn't kind of meet the scalability requirements with that. And I think it really comes down to is kind of MQTT's very much been designed for large scalability. And then HiveMQ, the broker, with our clustering infrastructure, you can kind of add more kind of broker instances to accommodate more scalability.
That's really interesting, and as you're well aware, and obviously you're designing a system around it, but the importance of data management now is really critical. It's not how much you can get; it's what you need and what you're viewing, and as you said there, what you're needing to sort of transmit on a priority basis rather than everything and all the time kind of thing. Just wanted to look at a little bit more focused on SparkPlug. So who's supporting SparkPlug specification today?
Yeah, no, good question. So there's a SparkPlug. It's being specified within the Eclipse open source community. Cirrus Link is the kind of, they created SparkPlug and then they brought it into the open source community to standardize that. So they're very much involved with that. They've got a partnership with Inductive Automation, where kind of inductive automation is kind of very much supportive of SparkPlug. There's Factory Studio supports SparkPlug with their new releases. So from the software side, companies like Factory, Inductive, Canary Labs supports it from a historian perspective. Just think, and those are kind of the main participants in the specification committee. On the hardware side, companies like Opta22, I think I'm pretty sure PLC Next has come out with a version of SparkPlug kind of just recently. A lot of the PLC manufacturers are supporting MQTT today, and my prediction is they'll layer on top of their MQTT support SparkPlug, because it's pretty easy to do once you've got MQTT support baked in. But we actually have a SparkPlug landscape diagram that goes through all the vendors supporting SparkPlug today on our website. I'd be happy to send anyone that wants that to them. So Nick, there was a question about kind of are there free versions available or commercial offering? If you don't mind, I'd like to just kind of take that one on.
Certainly, yeah.
So because it's so kind of how do you get going? How do you get started? So HiveMQ has a free download, free evaluation license of HiveMQ. It's limited to 25 client connections. So that's certainly, you can get going with that. We also have an open source version of HiveMQ that's free to use whenever you want. So there's no restrictions on that. It does not include our clustering technology though. So it's a very good MQTT broker. If you want kind of the reliability characteristics that we talk about, that you won't get that with clustering without the clustering technology. We also have HiveMQ Cloud, which is our managed service, and we provide free access to that up to 100 devices. So if you don't want to run your own broker, you can just kind of sign up for a HiveMQ Cloud account, and you can start connecting devices through that. Okay.
Thanks. We've got probably just time for one more question before we close the session.
Sure.
So this question, how different is HiveMQ in offering MQTT features compared to Azure IoT Hub and AWS IoT? Sure.
So yeah, so lots of, I think kind of Azure, Microsoft's very popular in the manufacturing world. So I think so. In Azure has support for IoT, they have support for MQTT. But again, similar to RabbitMQ, the support they provide for MQTT is not complete. And they actually say in the documentation that Azure IoT is not an MQTT broker. So they've actually kind of put support for MQTT on top of Azure, but they haven't completed the implementation. So they don't have, so you can't actually, for instance, use SparkPlug with Azure IoT because it doesn't support all of the features that SparkPlug requires from MQTT. So there's that instance. We also have customers that come to us from Azure IoT because they actually want to have a broker in the factory too. They want kind of, they've got this interfactory scenario where they want a broker in the factory that bridges into the cloud or kind of data center broker, right? And so Azure IoT doesn't have anything that you can run in a factory world. Okay.
Thanks, Ian. So we'll bring the session to a close now. Thanks very much for the presentation. Really interesting, as I said, really relevant. It's really interesting to get some insight into this platform, this data management structure, and highly relevant to what we're seeing out there in the industry at the moment. And it's obviously evolving as we speak, so it's not a given thing at the moment. And as you were saying about your clients, the different requirements and considerations that they have, it doesn't make it a very straightforward option all the time. So for our audience, thank you very much for joining us this afternoon. As always, the webinar will be uploaded to the AMS website and accessible in the future for yourself if you want to rewatch anything, or for your colleagues who might have been unable to join the live presentation. And you can access this and all our previous webinars via the Voice of the Industry link out on the site. So I'd like to say thanks again.
Thank you.
Taking part. I hope you'll join us again for our next week. And thanks again, Ian. Really good stuff.
Thank you.
Thank you very much.
Okay. Take care. Goodbye.